Hi, thanks for joining me for B-Side Splunk 2022. This talk is about innovating in cyber. We're going to use the Splunk's IP location feature to show how it'll work goes a long way. As we look at enhancing the IP location features in Splunk, we will discuss the thought process along the way, and hopefully this can inspire you to understand that innovation can start small and with anything. So when they told me that my talk was accepted, I had a moment and I realized that we need to get our data in for the talk. And I couldn't use my work data, but all I needed was IP addresses, and we can generate those. So I had a look at generating some IP addresses and pretty quickly realized, hey, Splunk's got a random feature, 0 to 254. This should do me. And I was like, well, that gives me IP addresses from all over the world. What are the chances of getting enough data from within Australia? So I started to think I'm going to have to find a routing table. Maybe I'm going to have to get some real data after all. That's going to get messy and it might even be a little bit too complicated. So let's go back to making them. How do I make just Australian IPs? Well, I thought to myself, who has lots of IP addresses? And I was like, well, telcos, ISPs, big ISPs. Yeah, this is the thought that I needed. So, who's a big ISP with national points of presence? And I picked one. Who's the most common name we hear all the time in Australia is Telstra, and Telstra's ISP side was Big Pond. So, no matter where you are in the world, you're going to have the same concept to go with. Now, in this instance, we can look up the Big Pond IP address, and then we can look up the whole range that's stuck to the same IP, and we can see the IP address range here, 61.9.128.0 through to 61.9.255.255. That's great. So now we've got some IP addresses to work with. It's hopefully going to get us a little bit further. Now, if you're at home, you can hit an API, grab some related to data off of your home internet connection straight off of terminal. I'm not going to show my home IP address, but that is something that you definitely can do if you're working from home. So here we have our scenario where we can make a whole pile of addresses. One thing to note here is that this evaluation is incorrect. It should have been random 128 plus 128 because we need to make a random number between 0 and 128, but our bottom number is 128 and up to 255. So that's our way of getting through, or 127 perhaps. So I made a little mistake there, and you're going to see what happens when you make a mistake in the next slide. Very simply, we can see that after making 10,000 IPs, we only got 5,023 that were usable because we had a mistake. So in this process of generating addresses, we've already made a mistake and now we can fix it. So having a go and trying is probably one of the most important things when it comes to innovating, creating, and just doing anything. Splunk's a pretty resourceful product. It's not something that's terribly easy to break. So have a go. We now have lots of IP addresses which relate to certain lats and longs according to the database, and we know the regions, and in some instances we even know the cities. So we should be feeling pretty good about things right now. So I came to the conclusion after doing this that I can do my talk. So at about this point, you're probably wondering, who is this guy? Who are we listening to? Well, my name is Ash, or Ash or Lee. You can find me on Twitter, Tweet of Ash, and you can find me on LinkedIn. And I love Splunking, and I'm here today to have some fun. Hopefully you are too. So when it comes to innovation, the biggest question that you're going to be asked is, what problem are you solving? What are you trying to achieve? This is the number one thing that gets asked. What problem are you solving? And it's a great question. Another way to put it is, what's wrong anyway? And you can see we have our choropleth maps and we have our cluster maps. And in America, our choropleth maps look beautiful. They've got shaded areas on a map. Our cluster maps pretty well operate for everybody outside of America. And they are those little dots where they show us, how many people, and we get these little pie charts everywhere on our map. And it's great, but it's not as beautiful as it is in America. That's what we want to fix. So essentially, we want to turn this into this. We want to turn that beautiful cluster map into something quite a lot nicer, into our choropleth map. And to do that, we need to know and understand a few components of Splunk. So we're going to have a look at a whole pile of components here. And the first thing is that we use our IP location data, and that IP location data really tells us what is going on. So we could revert to the documentation at about this stage and have a look, have a big read in the documentation. We know a little bit about cluster maps, they're working, but our choropleth maps are not. And we're going to use our geom data. We've discovered that from our documentation. And we're going to have a look at our KMZ or our KML files, which we've also learned from our documentation. So this is about following the bouncing ball and getting to that point in the process. That's how we're going to create our lookups. And when we look at our lookup options, we see that we have an option for GeoIP. That appears to be more something around updating the maximum database, perhaps. And we have some lookup files, geo_attribute countries, or geo countries for our KMZ file. Our KMZ files are compressed versions of our KML files. So we're going ahead in that direction. Now, just whilst I'm on the subject, MaxMind isn't our only option here. I found this lovely website which gave us a lot of geolocation IP data or APIs, and some of those are databases. You can see MaxMind's on the list there, DBIP. But some of these are available as downloads, some of them are purely APIs. But handy resource if you wish to integrate something else, you want to use a different resource for your IP database or your intelligence. Fantastic. So we're at this point in our process and we're like, we want to make this work. And that's what we're going to do. We've defined the problem. We've worked out why it doesn't work, why it doesn't populate. We've worked out what kind of data is missing. And we know this geom, this geometric data, geometries, KML files. So let's go straight to Google and see what we can come up with. And there's one more component that we can look into to figure these types of bits of information out, and that is our actual installation of Splunk. So if we look at Splunk, we can have a look at our lookups. And from within here, we see we have our GeoIP lookups, but it says that this is used to update the file used for GeoIP lookups. That doesn't seem like what we want. So let's have a look at our lookup tables, and we can see in our lookup tables that we have some interestingly named files. I think this is probably where we're going to be looking. Great. We've worked out a little bit more. We've got a few more hints. Again, this type of information might send us back to the documentation that would then show us the KMZ, KML. Even if we didn't go to our own documentation for that, we might just Google what is the file type KMZ, and we might find that it's a compressed KML, and then we can download a KML file and we can have a look at that. Also remembering that these are lookup files, we can possibly have some details out of those through input lookup. So let's have a look at our lookup definitions. And we also see that we have some very basic definitions here using those files. And this is great. So we can have a look at these definitions and we can see what they are. So they're type geospatial. Ooh, this tells us something as well. And it's using that file. There's no advanced options applying to this particular lookup, but we could use advanced options if we needed to. Great, we've got a whole bunch more information in our learning catalog, and we can move ahead with this type of information quite comfortably. Okay, Google, I need your help. I need to find what I'm looking for, and that is Australian map borders of the states. Might help if I spell it right. You know what? I've had a little bit of experience with Google. I'm going to try a little trick. File type, KML. Okay, I've got all these KML files now. Hopefully, this one might give us what we want. It's ausimple.kml. So let's have a look at that and see how we go. I've saved the file to the computer. Now we're going to switch over to Sublime and we're going to have a look at this file. Okay, so here we are. And we can see that we have some information on our screen. Well, this is my file, ausimple.kml. And when I look at Western Australia or South Australia, 1, 2, 3, 4 lines. 1, 2, 3, 4 lines. That's not a lot of information. For the borders of an entire state, a little bit worried about that. Let's see what that might look like. So to see what that looks like, we're going to switch to our Splunk instance and we're going to have a go. So we've got Splunk open and we need to add a lookup file to the instance. So we're going to add our own lookup file. And our lookup file will be the simple KML. This is great. Adding it to our search app, and we will call this GeoAuSimple KML. Okie dokie. We can save that, and following what we saw in the examples, we will create a lookup definition, and that lookup definition will very simply be GeoSimple. It will be geospatial, and it will be based on GeoAuSimple. So now we have our lookup. We can recompose our data. So we're going to put in our GeoAuSimple, And we have to set our feature ID field to be our region. That's the New South Wales or the Victoria or the Western Australia. At this point, we get something, and it really is a something. Let's have a look at this. So we're going to use our zoom, and as we zoom in, we can quickly see that we don't much care for these border lines, do we? Queensland, South Australia, New South Wales, Victoria, Western Australia. It's a bit of a mess. What would happen if we found a better one? Well, it just so happens that you might have noticed that over in Sublime, I have a second one. And that second one has a lot more information in it. So you can see this is our Victoria, New South Wales, Queensland, Northern Territory, Tasmania, South Australia. Oh, okay. Well, South Australia we saw had 4 coordinates. 1, 2, 3, 4. Look at all these lines of data. Western Australia, even if we don't know what this is, it certainly does look like a lot more coordinates. It looks like a lot more detail. So let's try and upload this one into our Splunk environment and see how we go with that. So again, we're going to go back to our lookups where we're going to add a new lookup. And this will be the AU simple. So this will be the, this will not be simple. This will be full border polygon. And we can see we have our AU full border polygon. We're going to upload this one and geo underscore AU states. Probably a great name for it within our system. And that's a .kml, not a comma KML. Okay, so this is going to be our file name now. We've uploaded this file and we're calling it this within our system. It's looking good. So we're going to set a new definition again. And we are going to be doing geospatial definition. It's going to come from our GeoAU states, and we're just going to call it GeoAU states. We don't need to worry about any of the advanced options because we're pulling the place marker name from the correct location. It's using default settings. So we should have a little bit more information, and it should look a little prettier now. Let's go. Oh, look at that. Doesn't that look pretty? So, a lovely Queensland, lovely South Australia, lovely Western Australia. We can change the formatting on this. Maybe we'll change it to a range of blues. Anything we like, really. Now, what we can do is we can actually use categorical in this instance, because in this instance we are sitting at a picture of specific numbers. There's not too many. We can see it categorical. This is great. So now we have full borders for Australia, and it's quite nicely defined. Hopefully this makes everybody feel a little bit happier, especially considering we included Tasmania. All right. So where did this lovely data came from? Well, that's the Australian Bureau of Statistics, and pretty well every country in the world, it's going to have a government agency that decides what the government areas are, the local government areas, those boundaries. So I went straight to our government website, and they have a lot of useful information here. Please make sure you have a good look around. You can jump into quite a number of states and territories shapefile. Here we go. Full Australia. and they've got it representing many different formats, lots of other information as well. So feel free to grab it how you like it. So just to recap, we've managed to make the boundaries of all the states look wonderful on our Splunk map, and we're pretty happy with what we've achieved so far. We've gone out to Google, we've found some data, we've uploaded that into our Splunk instance, and we have some nice looking information within our environment. That's part of the innovation process, is not rebuilding things, but actually working out how we can find what we need to know and then bringing it together. So we've gotten a lot of information out of MaxMind, and we can see that MaxMind does provide us with a lot of information. And it's going to be beneficial for us to have a look at the MaxMind documentation on their website. So if we jump over to their webpage, we can see we have our country, and we have our country within Europe. We have our CIDRs, we have our subdivisions, we have our cities, we have our postcodes and our metropolitan codes for within America. This postcode data is going to be quite interesting for us. Let's see how we go with getting all the way down to the postcode level within our environment and see what we can do. But before we do, we'll have a quick look. We'll get a latitude and longitude, which is what we were using for our cluster maps, and we were using our cities for our state boundaries, or we might have been using our domain. There's a whole bunch of different bits of information in here. So, and it says here, postcode data is available for 68 countries. So we can have a look at all of these countries that we're looking at. This gives us a lot of ideas. And we're probably going to have to revisit this at a later date if we want to expand to the rest of the world. But definitely worthwhile having a look at this at some stage in our process. But just for now, we're going to go to our Splunk instance, and we're going to have a little bit more of a look at what we can do within our environment. So the first thing we need to establish is that zooming in only goes so far. It's quite difficult to zoom in any further until we add additional details to our maps. Otherwise, we can't zoom any further. So you may have experienced when you were playing around that you can only zoom to level 7. We want to get a lot more detail in our map. So we're going to need to add the postcode boundaries, and we're also going to need to add a function called map tiles. So let's have a look at that and see what we can do. Okay. And within Splunk, as soon as we've downloaded our data, we can add those lookups. So straight back into the same process that we've already used. We're going to use a lookup table file. We'd like to add a new one. We're going to choose our file. And the file that we'd like to choose is going to be our newly discovered postcode file. And in this instance, we are uploading a file with one name, but we want it to be represented within our Splunk environment differently to comply with our existing naming structure. So we will use geo AU, and then we can call it postcodes. And that is a KML file. And we can click save here. Just like previously, we then need to add a lookup definition to the system, and we simply make sure that our app is set correctly. We give it our name, geo underscore AU underscore postcodes. This will become a geospatial lookup, and we will use our geo AU postcode KML file to create it. We click save. Okay, so now we have added some additional data to our Splunk environment, and we need to create some new lookups. So our first component is that we still want to make 1,000 or 100,000 bits of data, but instead of creating IPs this time, we just want to create some postcodes. This is great, nice and easy. We're just going to go from 3000 to 3200. And here's a little way for you to make it clear in your head. We're just generating a number between 3000 and 3200. Then we're going to add those up. And we've got 100,000 numbers being generated in that range. So we're going to have a few duplicates. And then we're going to use our geom and we're going to postcodes. And we're going to use the feature ID field as postcode. So now we've worked out what we want to type into the system. We end up generating some data. So with our data, we would like to zoom in all the way to Victoria, and we're going to try and zoom in to Melbourne. This is great. 1, 2, 3. Format, populate with current map settings. We want to go to level 10 on the zoom, but it's not letting us. We can see that there's more detail, but we can't zoom in any further. Let's have a look at using our tiles. Can we get any further now? Let's have a look. Sometimes we have to reload the page for this. Search. I always find putting it into a dashboard generally is a great way to get functions working. But we definitely have a better zoom now, and we can zoom in much more detail. This is great. This is exactly what we wanted. Let's go right ahead and save that into ourselves, a new dashboard. This is great. We've got our dashboard using our OpenStreetMaps tiles, and we can zoom in and we can see most of Melbourne based on these 3000 to 3200 postcodes that we've just populated. This is a very nice looking map, and again we can change this detail around, and one of the things that we saw previously was that if we used our categorical numbers, we got quite a lovely set of color ranges in here, but this time we have so many different groupings that we get a very large chart. Looks great, but maybe a little bit too much for us to use. So back to colors, and we're going to use a different setting. We can change it around in our reds and on and on. Now, another component will be our tile opacity. This is about 75%. You can have a look at 0% where you don't see these suburbs behind. And we can have 100% where we can see through quite clearly. Fantastic options there. What if we wanted to use a different mapping system instead of OpenStreetMaps? What if we're used to using Google? Well, that is a great question. And I have a Google map here for us using Google Tiles. It's the same scenario. We're just using Google Tiles instead. And we can do the same zoom into Melbourne and see the same data. So how did we do this? Again, it was just a little bit of Googling, a little bit of searching, found the documentation. And our tiles is quite literally just a different reference here for map tiles from Google. And we're able to populate straight out of Google. So this is very quick and nasty. Works. It's probably not the right way to do everything, but it does get us the results we're looking for. Once again, we can change the color, the tile opacity down to 0, and then we can have a very small, a very reasonable tile opacity. And you can also see that having 0 is the same as not showing the tiles, but it does give us the ability to zoom in. So we do require that information so that it can render to a greater depth. All right, we should be pretty happy with our tiling at this point. So what's next on the agenda? Well, if we have a look back in our thought process, did we get some? We sure did. Zoom, zoom, zoom. Can we get even more zoom? I mean, that's Google Street Maps. That's pretty good zoom level, right? Well, the truth is that there are ways for us to get better zoom, and let's have a think about this. So what I would like to do now is just show you a small sample of how we might like to lay out some data from this. And I've prepared a simple view of the White House. I've gone over to the Wikipedia and I've grabbed the White House SVG and I've downloaded that. So I'm just going to bring that up and we can have a quick look. I have placed the file into a part of the Splunk dashboard. So I'm going to show you exactly what we've done. If we click edit on here, this is an element that we've used. This is our SVG choropleth. And I've created a very simple search based off of the results I want to simulate, being that this is my map room. My map room is here. And I would like to change the value in the map room. At the moment, that is represented as a light value, and we're going to change that to a heavy value. So we can see that the map room changed its data, and we can see essentially what I've done here is I've created some values that I've put in, and we can have a look at how that's represented within the system. We've taken the ID string and we've taken the count over here, which is the number that we're taking from this value here. That's our value. So this is our count. So very simply, we're using this within a search to demonstrate the map room's weighting. So we can see we have our map room, and this is our menu item from here. So we can see this DD, which stands for drop down, and the random string. So we can see WD click C, WU click C. That's our token name. So we'll just bring the token across just to show this as a simulation. And I've thought that this could possibly be the Wi-Fi density. We could also use a similar function to track who's in a room at a given time. And we're going to have a look at that next. So this is our White House, and we could see this could be the Wi-Fi density. We can put multiple levels in. The really difficult component about this is actually the SVG and how we set that up. And I'm going to walk you through that shortly. In fact, let's do that now. So I've opened up the Inkscape application and got the SVG in, and we can have a look at our situation. So this is what the colors of all the squares look like. We can see all the different shapes, actually, not just squares. But this is the one that we've been looking at. That's our map room. Now, being computer people, we like to have a look around the place, pokey. This is a familiar icon for us. It says show me the code kind of thing. And in this instance, it's show us the XML tree of the document. And what I notice is that the selected item over here is changing as I'm changing my areas. And this is obviously the map room. And I can have a look at the breakdown. So we know in our situation we need to reference the ID of the component in the SVG that we wish to fill in. And we've read the instructions and it says that it needs a D record. So this is our record here. So that shows us a number of components related to the scalable vector graphic. So that is how we got the component that we need to color in. and that is how we know what we're coloring in based on this ID. So if you want to create your own, you're going to have to go through quite a bit of work with your SVGs to build that data out. And that's why I say this is actually the most work, the most labor intensive component of building out fantastic dashboards with SVGs. But it's absolutely worth it in the end. One of the ones we'll look at in a moment is a people finder, where we can take some data from somewhere in the organization, find a person on a map, maybe we can figure out where they're sitting, and we'll discuss a few different ways that we can look at that. But this was really important for you to see how we can look at the different components on the map, give them all an ID, and with that ID, we have the ability to color them in, and they need that D record as we discussed. So fairly quick and simple to do once you get used to it. I will say that if you go and try and create your own shapes, you might find that you've created a shape and you think you can color it in, but it might be set to be a rectangle and it might not have your D record here. So make sure you get these two components when you're creating your shapes, and you will be in a lot better position, and it'll function. You will start to be able to color in your SVGs, and they are essentially choropleth maps, and that is much more detail than we have when we're looking at just the Google Street View kind of level of zoom. The open tile, open maps, those tiles, the postcode data, we can zoom in. We can go to our own buildings and we can zoom into our offices. So I'm going to bring up now a couple of the other types of things that we can do, and we can have a look at those. And here is the same file in a text editor. So we can see it is the room map. We have our XML declaration. This particular one must have come from Adobe Illustrator using the SVG export plugin. So again, another component where we can get our SVGs, Adobe Illustrator. Believe it or not, a really simple place to get SVGs that you probably have on hand is Visio. Now, almost every network team has a Visio diagram of their network. We can illuminate that diagram in much the same way as we do with glass tables. We can light it up and we can put data all over that diagram, that SVG. So here we've got our declaration for our SVG. We can see this is come out of Inkscape most recently because I edited and saved it. And we can search through here for our room. So we had a map room, and this is our map room here. So this is a path with the ID of map room, and it's got an opacity. We could remove that if we wanted to. It's got its default fill color. We can have none if we wanted. And then it's got the dimensions there. So we go through, we've got our center hall, and we can see that we might have our China room and our different parts of the map, and they've all got their IDs. Here's a library. So we can color in many different parts as we see fit, and it's about getting to the data within our environment to determine what we want to highlight in the map. But this does show it's just a text file, which is one of the reasons why these images can be so small. So that's just something to keep in mind. It's a really big advantage. So it's probably at about this point where you're thinking to yourself, well, there's an awful lot of information to know. How do you just know all this stuff? Well, the truth is we don't. We have to try, we have to play, we have to read, we have to look at the options. And so there is some documentation. It's great. So it says here, In order for your choropleth SVG, the image must have a path with a defined T attribute. The D attribute determines the shape of the SVG outline using the pixel positioning. Okay, and we know that we're going to be addressing that item through an ID. So we've actually got within the documentation from Splunk a fantastic little demo here where we have our path ID. So this is our attributes that we need. Campus. So this is a demonstration campus, and we can see how that's lined up with the ID and then the D attribute. And then they've given us a tutorial here within the system for us to go and play with in order to build out a fully functional system. And this is great. This is going to show us how to have a look at some data within this map. And this is a fake campus, and it's showing our network connections within the different areas on the campus, which is awesome. Shows us how to formulate some sample data. Sorry if I can just stop scrolling so much. This is a great little tutorial here within the system. Fantastic way for you to learn how it works. The SVG is available for download, and I think this is a very good place to start, and it's certainly something that I would consider using. Have a go with that one and get yourself started. Now, before I get too carried away, I thought I better show you a little bit more about our problem, and that is geostats are lovely. So we've got our standard configuration here. We're creating some results. We've placed those results within Australia. We've looked up the locations, and then we're grouping those stats through. As we zoom in, we will find that we get our little clustering organized, and we can see we've got some in Adelaide, some in Melbourne, some in Sydney, and some in Hobart. And that is essentially what happens with our geostats. And that is our cluster map functionality, which works the world over. It's nice and clean and really easy, just not quite as pretty and not quite as detailed as we can get when we're moving all the way down to those tiles with our choropleth maps. So I'm just going to leave that there so that you can see it, and hopefully that has meaning for you as well. It's really important to note that Dashboard Studio and the classic dashboard don't have all the same options when it comes to our maps and our choropleth maps specifically. So we only have choropleth SVGs in Dashboard Studio, and our Google tiles are sitting over here in our classic dashboard. And when we go to convert that to clone in Dashboard Studio, we might find out that we have a little problem. Let's see what happens. The dashboard you tried to convert uses components that are not yet supported in Dashboard Studio. We apologize for any inconvenience. So there are some times when we're going to have to stay with the classic dashboard formats. That's absolutely fine. We don't mind. It's just making sure we use the right dashboard when we need it. Okay, so this is our Google Tiles copy. We can now delete that one because it's not going to do what we wanted it to do. I've got a few other little components here that I've prepared. One is showing our network connections in Dashboard Studio. So we have a campus, which is straight off of the demonstration we just looked at, and I've imported that into the environment. And if we click our edit button, we can see that we will be able to have a look at the campus SVG. We're using the ID string and the counts exactly as per the instructions. And we can have a look at the search that was associated. And this was the search that they recommended that we put together. So very simple. we've now got our dashboard. I've kept it clean and easy, but this is the demo, the example that we're given. And you can see, if you like, there's a lot more data on here, and it's much nicer than my version, which was pretty quick and nasty. This is a really beautiful campus map here. I've got an architectural floor plan here, which I've pulled off of one of those free websites. And we can see here when we're trying to find a person, that person's in room 7, Fred. And Barney is somewhere else in the building. Where might Barney be? Oh, he's in a little annex room off to the side here. And we can have a look and we can see, where is Pebbles? Pebbles is in room 1. And we can go back to looking up Fred again. He's in room 7. So we can create a people finder if we wanted to, and you could get your data from quite a number of different sources within your organization. What I do in my organization is that we have a CMDB configuration database. It tells us the MAC addresses of all the machines, as well as who owns those machines, and we're able to use those MAC addresses to correlate against the switch logs to find out which MAC address is connected to which switch, and then we can look that up with the network team and find out from their information where that port is connected to in the building. And now we know that he's in room 7. So that's the type of information that we can correlate within our environment, just by bringing the correct resources together, and we can create a people finder within Splunk. Now, Splunk might not have necessarily been designed to do this from scratch, but it didn't take us long to get here. Now, when I started my journey on this little talk, I didn't think I'd be putting together a GitHub repository for the data. I just thought I would be demonstrating something. But a couple of people spoke to me about that and said, hey, why don't you do this? And then we can all collaborate and we can slowly build this data out for the whole world. And I thought that is a great idea. So I've just put this here, and once I get the opportunity, I will go through and verify the copyright on the data that I have, and then I will add that to the repo, or I will get some alternative data and make sure that we get something in for Australia and for those postcodes. Hopefully there's a few other people out there that can do the same in other countries, and we can grow, and slowly we can cover the whole world, which I think would be beautiful. So if you've got any information for your country, or you find it and you want to contribute, please let me know. Thank you very much for that. I look forward to growing that little project on the side. So now for the non-technical component, and that is just briefly to say that management do like to tell visual stories, and they do like to see a return on their investments. So they've invested in Splunk, and your job is to make sure that they can see that that's telling great stories. And that's one of the reasons why we love the choropleth maps, and that's one of the reasons why the choropleth SVGs have a lot of power and a lot of potential. If we do a good job with our dashboards, they justify Splunk, and we end up getting bigger budgets for more toys. So hopefully that helps you decide that you want to do more. So just going to open it up for some questions, and if anybody's got any questions, please, you can speak up, or we can jump straight through to thank you very much. But hopefully there's some questions, and I think we might get an early minute. Okay, thank you very much, people. Have a great day.